Hey guys, here we are to talk about 5.7 notes, which is the Pythagorean Theorem. I'm going to show some ways with decimals and some with simplified radical form, which is what they do on the ACT. So just wanted you to be able to see both. We're going to start just with a reminder of the Pythagorean Theorem. If you have a right triangle, then you can say a squared plus b squared equals c squared. And I think we've done that a decent amount of times before. So the hypotenuse is the longest side. That's always c. So in the reverse order, I just want to kind of expand on the Pythagorean theorem. If you know that a squared plus b squared equals c squared, then you can say it's a right triangle. So Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. So like if it's a right triangle, then a squared plus b squared equals c squared. But the converse says if you know a squared plus b squared equals c squared, then you can say it's a right triangle. So that should be a little bit of review. What I want to add new to it is, what if a squared plus b squared does not equal c squared? So if a squared plus b squared is smaller than c squared, aka the c squared is bigger, then you're not going to have a right triangle, but you're going to have an obtuse triangle. See how the c squared is, or the c is longer? This picture makes it look like an obtuse triangle. And so when that c squared is bigger than the a squared plus b squared, you're going to have an obtuse triangle. On the other side of things, if you have a squared plus b squared and c squared is smaller, then you're going to have an acute triangle. So you can kind of see there the acute triangle. So we're going to do a lot of different practice problems. I did this on video so that you could go back and see ones that you guys needed help on. Okay, so we'll start with this one. It says, what is the length of the hypotenuse? So we can start there, regular Pythagorean theorem, a squared plus b squared equals c squared. C is the longest side, so 8 squared is 64, 15 squared is 225, and that together gives us 289. We'll take the square root of both sides, and that gives us 17 for C. So not bad so far. But they did ask us a second question. They said, do they form a Pythagorean triple? So that's a new term I don't think we've heard. A Pythagorean triple is when all three sides are whole numbers and it's a right triangle. So a squared plus b squared equals c squared works. So this is a Pythagorean triple because 17 is whole, 8 is whole, and 15 is a whole number. And 8 squared plus 15 squared does equal 17 squared. So it's a right triangle. We see that right here, and these are all whole numbers. So yes, it's a Pythagorean triple. It would not be a Pythagorean triple if any of the numbers were decimals or if it did not make a right triangle. So if it was an acute or obtuse, it's not a Pythagorean triple. If any of the sides are decimals, it's not a Pythagorean triple. So let's solve this one. They want us to solve for x. It says in simplest radical form. So I'm going to do decimal form, but I am going to show you this. This is what they do for the ACT. So if you're doing Pythagorean theorem, we know we have a right triangle. So we can do Pythagorean theorem. 100 plus x squared, 16 squared is 256. So when I take the square root of this, x is equal to, square root of 156, that's 12.490. Okay, so this is not a Pythagorean triple. And that's because that's a decimal. So this is your answer for x, but on the ACT, they won't have that as one of the multiple choice. What they do instead is they do the whole thing very, very similar. So copy and paste that. But when they get to the end here, they say x is equal to the square root of 156. And then they break that down. They say 156, and they look for some number that is a square root, a perfect square root. So like 1 squared is 1, 2 squared is 4, 3 squared is 9. So I'm going to try dividing that by 4. 156 divided by 4 is 39. 39 is a prime number. And 4 is a perfect square. So the square root of 156 is the same as the square root of 4 times the square root of 39. The square root of 4 is the number 2, and then 39 is 13 times 13 times 3, which is none of those are any of these perfect squares. So I'm just going to leave that. And this is how they'll write their answer. So it is the same thing as the 12.49, but the ACT will write it like this. So you don't have to worry about this. I just wanted to show that for people who might want to know for the ACT. So not a Pythagorean triple. The answer is 12.49, or ACT answer 2 times the square root of 39. So 39 is 13 times 3, and those can't, those are not any perfect square roots. Let's keep going. Here's a little application. Jamal leans a 12-foot ladder against the side of a house. Ooh, you guys are getting to see my beautiful house drawing skills, aka thank you, Notability, for drawing a triangle for me. The base of the ladder is 4 feet away from the house. So from here to here is 4 feet. And they know that the ladder is 12 feet long. So I'm going to draw the ladder, which is, I got to make this pretty for you guys. There we go, all the rungs of the ladder. And that ladder is 12 feet. So we made a little assumption here. We assume that our house makes a right angle with the ground. Hopefully your house does. I'm not going to lie, I looked at my house and it was a little bit off just because the construction wasn't perfect. But the idea is that a house should be perpendicular with the ground. So they want to know how high on the house does the ladder reach. So this is what we're looking for. We'll call it x. And we can just do Pythagorean theorem. 4 squared plus x squared equals 12 squared. So 16 plus x squared is 144 minus 16. And x squared is 128. Square root both sides. And that gives us 11.3. It said round to the nearest tenth of a foot. So 11.3 feet. If you wanted to convert that 3 feet into inches, it was actually 0.3137. It was that many feet. So you could convert using what you learned in physics. 12 inches are in 1 foot. So 0.3137 times 12 is a 3.7644 inches. So basically 11 feet and 4 inches up the house, or 11.3 feet. If you want to use the ACT method, instead of doing 11.3 feet, they will take the square root of 128, which was our answer for x, and they're going to break it down. So again, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and we could keep going. So actually I will keep going. 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. That 128 is divisible by 2, and if you cut it in half, that is 64 each. I'm going to write it with the 64 in front. 64 and 2. And so x is equal to the square root of 64 times the square root of 2. The square root of 64 is 8, and then 2 is a prime number. It is not one of those perfect squares. So they would leave their answer like this, and then feet. So you can do the 11.3, but if you want to practice for the ACT, that's what you would see. Okay, now they want to know if it's a right triangle, acute, or obtuse. So remember, if a squared plus b squared equals c squared, it's a right triangle. If a squared plus b squared, if the c squared is bigger, then it's an obtuse triangle. And then if the c squared is smaller, it's acute. So let's just test it for this one. The longest side is going to be your C, so that's the 32.5. So 12.5 squared plus 30 squared, and then comparing that to 32.5 squared. We already know it's not a Pythagorean triple because of the decimal points, but let's see what kind of triangle it is. So 12.5 squared is 156.25, 30 squared is 900, and 32.5 squared is 1056.25. So these two added together is 1056.25. This is 1056.25. And since those are equal, we can say it is a right triangle. And our reasoning there, I'll kind of explain it verbally, is because the Pythagorean theorem does work. A squared plus b squared does equal c squared. So it's a right triangle. Sometimes it's not. So let's look at this last one. It says a triangle has side lengths of 4, 9, and 12. And don't forget from the last section, if they didn't tell us it was a triangle, we could check 4 plus 9, 13 is bigger than 12. That works. 4 plus 12 is bigger than 9. That's 16 is bigger than 9. That works. And 12 plus 9 is definitely bigger than 4. 21 is bigger than 4, and that does work. They told us it was a triangle, so we didn't technically have to do that. But it is a triangle, and then we're going to see what type. So 12 is C, because that's our longest side. So 4 squared plus 9 squared. We're going to compare that to 12 squared. So 16 plus 81, compare that to 144. So this is 97 and 144. The C squared is bigger in this case because 144 is bigger than 97. So it is obtuse. So you do not have a Pythagorean triple because it's not a right triangle, but it is an obtuse triangle because that C squared was bigger. So that's our explanation. That's the last one of the notes. I thought it would be good to be able to go through these. Some of the homework problems are pretty difficult compared to this, so I thought it would be better to do the notes ahead of time, and then I can help you in class with the homework. Hope you guys have a good rest of your night. Thanks.